Statistics and probability. A skill check. 1. If a die is rolled, which of the following is more likely? Select the correct answer. A number less than 3. Well, you've got to think of outcomes. How many numbers are less than 3? There's only 2 numbers less than 3. An even number? Well, there's 3 numbers that are even. A number that is 3 or more? Well, that's 3, 4, 5, and 6. So that's 4 numbers. And a number that is a prime number? Well, a prime number is going to be 2 and 3 and 5. And that's only 3 numbers. 2. A bag contains 5 10-cent coins, 4 20-cent coins, and 3 50-cent coins. A coin is drawn at random from the bag. How many outcomes are in the sample space? Well, the outcomes is how many different results can you have. If you only pull out one coin, well, the only outcomes possible is a 10-cent, a 20-cent, or a 50-cent. So when they say how many outcomes are in the sample space, that would be 3. That would be either a 10-cent or a 20-cent or a 50-cent. Are the outcomes equally likely? Well, there's 5 of those, 4 of those, and 3 of those. What do you think? 3. For the spinners shown, that's a spinner, the red sector is twice as large as each of the other sectors. Find the probability that when the spinner is spun, the arrow lands on a red. Well, if this red is twice the size of the others, then you just add them up and you got 1, 2, 3, 4, 5, 6. So there's actually 6 possible outcomes, except we know that red could come out twice. So there's really only 5 outcomes because 2 of them are the same. So when it says the probability that when the spinner is spun, the arrow lands on red, well, that's 2 out of 6. And B, purple or blue, so again, that's 2. 2 of them out of 6, right? There's 2 there, and there's 1, 2, 3, 4. So that's 2 out of 6. Not green, well, that's 1, 2, 3, 4, 5 that aren't green. So that would be 5 out of 6. 4, a normal die is rolled. What is the probability of rolling a 7? Well, the probability is 0. There's no 7 on a die. A number less than 7. Well, the number less than 7, well, that would be the probability they're talking about now. So the probability, that's every number, right, is less than 7. That's 1, 2, 3, 4, 5, and 6. So the probability is 6 out of 6, which is 1. 5, the probability of Danica hitting a bullseye when playing darts is 0.6. What is the probability of Danica not hitting the bullseye? Well, it's 1 minus 0.6. 6, Aditi bought 10 tickets in a raffle in which 400 tickets were sold and there is only one prize. What is the probability that Aditi will win the prize? Well, that's 10 divided by 400, which is 1 divided by 40, which is B, 2.5%. 7, the probability of cloudy skies tomorrow is 0.85. What is the probability of clear skies? Well, that's 1 minus 0.85. Relative frequency. Experimental probability is based on the results of a trial that has been repeated many times, such as testing the effectiveness of 100 light globes, or relies on past statistics, such as the number of babies born last year who were girls. It estimates theoretical probability using relative frequency, the number of times an event occurs compared to the total frequency of outcomes. And there's the summary. Experimental probability, okay, is the number of times the event happened divided by the total number of trials, or the frequency of this event E divided by the total frequency. Expected frequency is the expected number of times an event will occur over repeated trials. Expected frequency equals theoretical probability times the number of trials. This will make a bit more sense as we move on. Example 1. James rolled a die 100 times and recorded the results in a table. A, find the experimental probability of rolling an even number. Well, the important thing to remember is this 100. If he rolls it 100 times, the frequency column must equal 100. If he rolled it 50 times, all those numbers would add up to 50. Find the experimental probability of rolling an even number. Well, the even number is 19 plus 12 plus 17. That's 48. But they asked for the experimental probability. So how many times did he roll at 100? 48 of those times we get an even number. So it's 48 divided by 100, and that's 12 over 25. An even number or a number greater than 4? Well, an even number is going to be 2, 4, and 6, or a number greater than 4 would also be 5. So that'd be this one as well. So we've got the even number 19, 12, and 17. plus a number greater than 4, well, that'd also be the number 5, so we add 18. So basically it's our 19, 12, and 17 that we had for the even numbers, plus 5, which is 18. That adds up to 66. It's the relative frequency, the experimental probability, and that is 66 divided by 100, or 33 on 50. An even number less than or equal to 4, well, an even number less than or equal to 4 would only be 2 and 4, so that's 19 and 12. So 19 and 12, that's 31, divided by 100, because it was 100 rolls of the dice. The frequency was 100, so that's 31 on 100. Okay, same example. B, calculate the probability of rolling a 2 or a 3 as an experimental probability. Well, the experimental probability is from our experiment here, a 2 or a 3, so it's a 2 or a 3. Now, when you see or, that's both together, so that's going to be those two added together, and that's 30. 19 and 11 is 30. 30 divided by 100, because that's how many times it was rolled, is 3 on 10. The theoretical probability, however, a 2 or a 3, okay, so a 2 or a 3 means getting a 2 or a 3. So that would be a 2 in 6 chance, because there's 6 outcomes, and a 2 or 3 is 2 of those outcomes. So that'd be 2 on 6 or 1 on 3, which is quite close, right? 3 on 10 is 0.3, 1/3 is 0.333. Okay, C, if the die is rolled 100 times, what is the expected number of times of obtaining a 2 or a 3? So we're going to use this information here. How does this compare with James's observed number of times? And we're going to use that information too. So the expected number of times of a 2 or a 3, well, if we found out it was 1/3 there, and there was 100 rolls, that's 1/3 times 100, which is 33.333, about 33 times you'd expect to get a 2 or a 3. From the table, the observed number of heads was 19 plus 11 plus 30. That comes from here. And that's close to 33. So they're pretty close, huh? That's 30, in fact. Okay, now here are the exercises on relative frequency. Very similar to the example. Ashima spun this spinner 200 times and recorded the results in the table. They're the different colors. That's the frequency. 200 times, so those numbers there, when you add them up, should equal 200. Because the frequency is the number of times it was spun. A, calculate as a decimal the experimental probability, relative frequency that the arrow points to. Okay, red, but remember this is the experimental probability, so we're using our table here after the 200 times that it was spun. So red is 85 divided by 200, and remember as a decimal. Blue, 28 divided by 200 as a decimal, and green, 42 divided by 200. Now, B, calculate as a decimal the theoretical probability that the arrow points to. Now, the theoretical probability is not the table. It's just theory. We've got 8 parts, okay, and for red, there's 3 of those 8. So the as a decimal is going to be 3 on 8, but as a decimal. Blue, there's just one blue, but there's 8 outcomes, and one of them could be blue, so that's 1 on 8 as a decimal. Green, there's 2, so that's 2 on 8 as a decimal. Are the experimental and theoretical probabilities similar? So you'd compare them. For 200 spins, what is the expected frequency of red or purple based on the theoretical probability? Okay, this question's asking us about red or purple. Well, red or purple, there's 3 reds and 1 purple, so 4 out of 8 outcomes could be either red or purple. So that is a half. So red or purple, the expected frequency of red or purple based on 200 spins is going to be 100. And when we add up red and purple, we get 115. And how does this compare with the observed frequency? So you can compare 100 to 115. Question 2, very similar to question 1. Make sure that you understand the terminology, relative frequency here, theoretical probability, comparison here, and in fact, very similar to the previous questions, so good luck with that. An important thing to note, though, is this, that after the marble is selected and the colour is recorded, the marble is returned to the bag. So as we go forward, that's an important distinction for this question here, that once you pull out the marble, you put it back in before you take the next marble. Question 3 looks like a lot of fun, tossing a coin and doing it 100 times and writing down the frequency of heads and tails. If you'd rather not use a coin, you can find some websites that have an applet that you can do this experiment on, and that might be a little bit better than chasing a coin around a room. Question 4 is much like the example that we saw at the beginning of the video. So that looks like a good one. This number 5 is another experiment you can do at home, but you'd need 5 blue counters, 2 red counters, and 3 yellow counters. Again, you might be able to find a nice website that you can select how many of each counter in a bag, and then it would randomly choose from the bag. It's important to note that once the counter's been pulled out of the bag, it's put back into the bag before the next counter is pulled out of the bag. It's got an extra column here for tally. That's for you to use. So you can, if you do actually do it at home, then you would want to just tally it, which is just putting those vertical strokes down, and you get 4, and then you cross them, and that's 5, and that's tallying. And then you add all of them up, and you get the frequency. Question 6 is similar to the first question. Question 7 is similar to question 4. Question 8 is presented differently here. 8, 2 dice are rolled, and the sum of the numbers appearing uppermost was recorded in the frequency histogram. These are the outcomes. You can't get a 1 because we're counting the tops of both die. So that would be a 2 would be the minimum number you could get. And if you got 2 6s, 12 would be the top number. How many times were the 2 dice rolled? This is the frequency. So that means a 2 was rolled 4 times, a 3 was rolled 13 times. So you need to add these numbers, 4 plus 13 plus 13 plus 31, and you add all those numbers together, and that will give you how many times they were rolled, because that's the total of the frequency. And then this is very similar to what we did in the previous questions. Bit of a twist, but similar. Now, question 9 is very ambitious. It's got the usual kind of questions like how many students were surveyed. Again, you'd add up all that and you get a number here. These are similar to the previous examples and exercises. Number C is one of my favourite. What mode of transport could other include? Okay, just use your imagination there. And D is very ambitious, isn't it? You've got to survey 100 students at your school. Well, you might like to do that. Sounds like a great exercise.